Okay, here's an official science test, passage 1. And as always, we'll do the overview to see what we're dealing with. And if we look at passage 1, well, there's not very much to it, really. There's a few sentences of an introduction, there's a few sentences describing figure 1. We have table 1, and as always, I spend most of my overview, 90% of my overview, just looking at the tables. I rarely read anything in the science test. So I'm going to do that and see if the tables will give me enough information that I feel comfortable answering all the questions. If they don't, I might read a sentence or two, but it's always I go to the tables and the graphs first and see if by doing that, I think I've got enough information. So we'll go over to the passage and we'll look at table 1 right here, and it has 3 columns: phase, start, end, phase, latent phase, a contraction phase, and a relaxation phase. And then start would be the onset of the sound, begins to increase, it begins to increase, begins to decrease, decrease. Okay. And I'll just read. It says figure 1 shows the force generated by an adductor pollicis, thumb muscle. Okay, undergoing an isometric twitch. Okay. And then we come over to this graph and we see that along the bottom is time in milliseconds, and it's going from 0 to 300. And up the side here we have force in whatever n is. And we just see that the graph increases, then decreases, and then goes flat. And then it's got this little enlargement of the shaded area. They wouldn't do that unless it was in a question, so it's just at the beginning, and it's just showing, I guess, when this kind of starts. It's sort of, this is when I guess the twitching, whatever that is, starts. Okay. Yeah, so it's a thumb muscle twitch. Yeah, I don't think I really need to read any more than that. So I will go straight into the questions, and as always, if a question requires me to read something, then I'll do that reading at that time. So, question 1. According to figure 1, over which of the following time periods of the isometric twitch of the adductor pollicis does the force generated by the adductor pollicis both increase and decrease? Alright, so the thumb muscle. Alright, so we're doing our step by step. Step 1 will be to find figure 1. Over which of the following time periods of the isometric twitch, so that'll be number 2, we're looking for a time period, and then we're looking for the time period when the force generated increases and decreases, and that gets a little asterisk because that's our answer. We have to find when it increases and decreases. Right, so figure 1, I'll enlarge it here. So we do step 1, we've found it. Over which of the following time periods? Okay, so we're looking, this is time along here, so we've found number 2. Does the force generated? Number 3 is here, so that's, we need to find this. Does it increase and decrease? Alright, so increase and decrease. So we have 0 to 50, 50 to 100, 100. Okay, well, let's look at them. 0 to 50 is here, so what's the graph doing between here and here? Well, it's just increasing, so that one's out. Between 50 and 100, between 50 and 100, what's it doing? It's increasing and then it's decreasing. You can see that the top's here and then it's starting to come down. So if I was in the exam, I would just say it's B, thank you very much, and move on. But just to be complete, I'll show that the other ones are wrong. 100 to 150, so that's 100 is here to 150. What's it doing? It is just decreasing. It is out. And D, from 150 to 200. What's it doing? It is just decreasing. So there you go. Proof is in the pudding. It's B. Right, based on table... Note to self, don't move it so quickly. Let me get rid of that, because it's messed up one of my answers. Right. Question 2. Based on Table 1 and Figure 1, Table 1 and Figure 1, what is the correct order of the 3 phases, okay, of the isometric twitch of the thumb muscle from the phase with the shortest duration to the phase with the longest duration? So we'll get step 1 is to find those 2 figures. Step 2, we need to find the correct, well, I think that's step 3 because that's the last thing we have to do is find the correct order. Step 2 is find the shortest duration and the longest duration. Alrighty, so let's see what we have to do there. So we're going to be using both of the graphs that we have on here in the table. Because table 1 has the periods and the phases. So step 1, we found table 1 and figure 1. What is the correct order of the phases? From the phase with the shortest duration to the phase with the longest duration. And we have latent period contraction. So yeah, we're looking for these things as they relate to this graph, because we're using both of them. So the latent period, when does it start and when does it finish? It's the onset of the stimulus and the force begins to increase. So we have to come over to the graph and we see onset of the stimulus is obviously just after 0. And when does it start to increase? Well, almost immediately. I mean, it starts, I mean, you can actually see it in this inset here. It starts to increase around about 2. It starts to come off. It starts to actually happen. So it starts at 2, or it starts at 0, sorry. That's the onset of it. And it starts to increase at 2 seconds. So that's very short. So that's the latent period. Contraction phase, the force begins to increase and then it begins to decrease. So it begins to increase at 2. We already got that one. And it increases, and then it starts to decrease about there. Or yeah, so it's about 90 something. Because it, yeah, so it's about 2 to 90, I don't know, 8, say. And then the last one, the relaxation phase. It's when the force begins to decrease and then it stops decreasing. So it begins to decrease kind of here, right? That's when it starts to, and it comes down and it's still decreasing, and around about here it goes flat. So that's from about 98 to about 260 or something. So clearly the shortest phase is latent. Then we have 96, we have about 96 of a difference here, and then this one's 100 and something. So it goes on the longest. So it's actually 1, 2, 3. And we see that from our answer choices, that is F. Don't know why it's moving like that. It is F. Latent contraction relaxation. Okay. According to figure 1, during the isometric twitch of the thumb muscle, the time that elapses from the start of the twitch until the muscle contracts with the greatest force is closest to which of the following? All right, step 1, find figure 1. The time that elapses from the start, all right, we have to find the start, until the muscle contracts with the greatest force. We have to find the greatest force and then find which of the following. So what's the value of it? That's 4 is our answer. Okay, so we have to come over here and I'll get rid of all of that. It's awfully messy. Go ahead. Right, so find figure 1. Step 1, we've found it. Elapses from the start of the twitch. So the start of the twitch, we sort of worked it out from actually this one. I mean, if you're being that precise, it's here's 0 and it starts around about 2. So that's in here. So it starts about 2 And its greatest force is when, this is force up here, so we're looking for the highest value, and that's about there. And it's asking us for the time. We need the time that elapses, that's 4. So how long is that? So it goes from about 2 to about 97 or something, maybe 95, 96. And we come over to our answers and we see that that is B. We could have looked at the answers first, but it's not going to give us that much information. But yeah, it's answer B. Right. Number 4. If a thumb muscle is stimulated multiple times at a high frequency, it can undergo a tetanic contraction, a sustained muscle contraction that prevents relaxation. In this state, the muscle generates a force that is about 2 times the maximum force generated during an isometric twitch. Based on figure 1, during a tetanic contraction, the muscle would generate a force of about. This is a typical ACT type of question, in that it is trying to throw off students by introducing something completely new, a tetanic and complicated sounding. It's all the better for the ACT question makers if they can make it sound really hard. Tetanic contraction. And they're trying to throw off students who think, oh, this science test is so hard. They're talking about tetanic contractions. They're talking about, you know, adductor pollicis. And, you know, all it's there for is to confuse you. That's it. Just to make you think this is harder than it is. And you have to, the more you do these questions, I keep going on about how you learn so much just by doing official ACT questions. But this one, if you do, you know, 15 or 20 tests, you would spot this a mile away and you would look at that and think, I know exactly what they're doing. They're just trying to throw me off by bringing in a fancy term that sounds really complicated. And I know the question is absolutely basic. And I'm going to show you what I mean. So we'll do our steps. Based on figure 1. Right? A tetanic contraction, sustained muscle contraction that prevents relaxation. In this state, the muscle generates a force that is about 2 times the maximum force generated during an isometric twitch. And the isometric twitch is what graph 1 or figure 1 shows. During a tetanic contraction, the muscle would generate a force of about. From here, why is it not working? From here to here, all this stuff, the tetanic contraction stuff, is nonsense. This means nothing. All it's saying is, the question this is what the question boils down to. What is 2 times the maximum force shown in that graph? That's it. That is what that question is asking. And if you have done enough questions, you would see that in seconds that that's exactly what they're asking. So all we need to do is find, step 1, find figure 1, and that's here. Step 2, find the, hang on, step 2 is here, step 3 is, step 2 is find the maximum force. All right, force is up here. What's the maximum force? It's when it's at its peak. What's that? But 7.5? What is 2 times 7.5? I would say it's 15. And we find that in answer choice G. See how simple it is when, and they did it absolutely deliberately to put in those first 3 or 4 lines just to make this sound so very complicated and get students to panic. If you do enough questions, you'll never panic over a question like that. And you'll see it a mile off and be able to answer it in seconds. All right, question 5. According to figure 1, during the isometric twitch of the adductor pollicis, or the thumb muscle, the muscle begins to generate force at approximately which of the following times? Right, so step 1, find figure 1. Isometric twitch, the muscle begins to generate force at approximately which of the following times? So when does it begin? So number 2, when does it begin? That's all it's asking us. And it's got 2 milliseconds before the stimulus occurs, 10 milliseconds before, 2 seconds after, 10 milliseconds after. And it looks like this is where they really are asking about this little thing, because this is kind of a little blow up of the very start, when the stimulus starts. So what does it tell us? And I think we actually know the answer. We've answered it before. We were saying it was 2 seconds. It shows us that here's where the stimulus starts, and when does this, it doesn't really happen, and then about 2 seconds it starts to take off. So our answer is 2 seconds. 10 seconds isn't anywhere in this thing. So we can get rid of B and D. And it's either, is it before the stimulus occurs or after the stimulus occurs? Well, the stimulus starts at 0. This is before, obviously. Well, nothing's happening before it. And this is after. So it's 2 seconds after. Simple. And that would be 2 seconds after the stimulus, C. And that's the end of this passage, and it was very straightforward, nothing complicated to it at all.